Hi Cambridge class! This week in maths we'll be looking at fractions, and today we will be looking at equivalent fractions. So equivalent doesn't mean the same or identical necessarily. Equivalent means the same value or the same amount. So for example, we've got a 1p and a 1p. Two 1p's are not exactly the same as one 2p, but 1p add 1p is the same as the value or the same amount as the 2p. So together they both make 2p, but they don't look identical. Similarly, we've got here 10 1/100ths, and over here we have got 1/10. So if I add all these hundredths together, it's the same value as 1/10. But just looking at those 10 100ths, they're not identical to this 1/10. We're going to be working a lot with bar models today, so on the page you can see a strip of paper. I've cut the first strip of paper into 2 parts, and I've cut the second strip of paper into 4 parts. What do you notice? Pause the video while you think about it. Something that I notice is that the parts that I've cut them into are exactly the same size. The parts have got to be equal with fractions. I know that if I cut them into halves, I've got 2 equal parts. If I cut them into quarters, I have got 4 equal parts. I can see that I've got a half and a half when cutting them into halves, and I've got a quarter and a quarter and a quarter and a quarter when cutting them into quarters. I can start to see equivalent fractions here. I can see that 1/2 is the same size, same amount of space as a quarter add a quarter. So 1/2 is equivalent to 2 quarters. There's a pattern that we can use when helping us with things that are equivalent to a half. The numerator is 1, the denominator is 2. So the numerator multiplied by 2 equals 2, and the denominator divided by 2 equals 1. So 1/2 is the same as 2 quarters. The numerator multiplied by 2 gives us 4 as the denominator, and the denominator divided by 2 gives us 2 for the numerator. So when you're thinking about fractions that are equivalent to 1/2, the denominator is always twice as big as the numerator. The numerator is always half the size of the denominator. Now, using that idea, I'd like you to think about which numbers are in the gaps. Pause the video while you work out the missing numbers. Okay, so here I have got 3 as a numerator, because the denominator divided by 2 gives you the numerator for fractions that are equivalent to 1/2. And here the denominator is 20, because the numerator multiplied by 2 gives you 20. Now here you've got it's a number line, and we've got 0 at this end, 1 at this end, and we have got 4 jumps. 1, 2, 3, 4 jumps, which means they're going up in quarters. So 1 quarter, 2 quarters, 3 quarters, and then this is 4 quarters, which is the same as a whole one. And we're going to have a look at these fractions, 2/8, 5/20, and 3/12, and think about where they would be on this number line. So again, bar models are really useful for equivalent fractions. For 2/8, I've got 0 and I've got 1 again. I've got to split my bar into 8 equal parts, and I just need shading 2 of them for 2/8, and I can see that 2/8 is equivalent to 1 quarter. For 5/20, I need a bar that's exactly the same size as the other bars. This time it's got to be cut into 20 equal sections, and I would like to colour in 5 of them and I can see that 5/20 is equivalent to 2/8 and a quarter. And then for 3/12, I have got a bar split into 12 equal parts, shading 3 of them, so 3/12, 5/20, and 2/8 are all equivalent to 1/4. Thinking about a pattern here, what do I multiply the 1 by to get 4? 1 multiplied by 4 gives you 4. What do I divide the 4 by to get 1? So 4 divided by 4 gives you 1. And you'll find that this happens for all of these because they're all equivalent to 1/4. So 2 multiplied by 4 is 8. 8 divided by 4 equals 2. 5 multiplied by 4 equals 20. 20 divided by 4 equals 5. 3 multiplied by 4 is 12. And 12 divided by 4 equals 3. Pause the video while you write down 3 other fractions that are equivalent to 1/4. So all I need to do is think of a numerator and multiply it by 4, or think of a denominator and divide it by 4. So if I had 4 as a numerator, multiply by 4 gives me 16. If I had 6 as a numerator, multiply by 4 gives me 24. And these are all equivalent to 1/4. Think of a denominator and divide it by 4, and I'm going to get 8. And there's many, many more. As long as your denominator is 4 times bigger than your numerator, then it's equivalent to 1/4. So now have a go at filling in these gaps. Pause the video while you do this. Okay, so 1 multiplied by 4 gives you 4. So the denominator divided by 4 gives you 2. 3 multiplied by 4 is 12. 20 divided by 4 equals 5. And then here is anything that's equivalent to 1/4. So let's have 7 this time and 28 at the bottom, but you can have lots of other ones. And what do you notice? So we talked about how this number is 4 times bigger than this number. But look over here. If I times this numerator by 5 to get 5, I've got to multiply the denominator by 5 to get 20. 1 multiplied by 3 is 3. 4 multiplied by 3 is 12. 1 multiplied by 2 is 2. 4 multiplied by 2 is 8. 1 multiplied by 3 is 3. 4 multiplied by 3 is 12. So there's patterns going from the numerator to the denominator, but whatever you multiply the numerator by, you've got to also multiply the denominator by. So there's 2 different patterns. Now you're thinking about that, I'd like you to have a go at filling in this missing one. Pause the video while you write it down. So it's hard at this time to think, what do you multiply 3 by to get 4? But you can go this way. What do you multiply 3 by to get 12? You multiply it by 4. So here you multiply the denominator by 4. Whatever you do to the bottom, you do to the top. Whatever you do to the top, you do to the bottom. So if you multiply the numerators by 4, you multiply the denominators by 4, and you get 16. So 3/4 is equivalent to 12/16. So 3/4, a bar cut into 4 equal sections and 3 sections shaded in, is equivalent to a bar with 16 sections, 12 of them shaded in. 3/4, 12/16. It's the same amount. Now have a go at these 2 questions. Pause the video while you work it out. So we've got to start from the bottom, from the denominators. 4 multiplied by what equals 12? 4, 8, 12. Multiplying it by 3. So whatever you do to the bottom, you do to the top. 3 times 3 equals 9. But work with the denominators again. 5 multiplied by what equals 15? So multiplied by 3. And I can't work this way, so I've got to work the opposite way. I've got to do the inverse. So 9 divided by 3 equals 3. And just check. 3 times 3 is 9. 5 times 3 is 15. This is now the last slide. Something doesn't seem right. Can you work out what's gone wrong and write down the correct fraction that is equivalent to 3/7? Pause the video while you do this. So what's happened is that the 3 has been multiplied by 3 to get 9, but the denominator, the 7, has been multiplied by 2 to get 14. But whatever you multiply the numerator by, you've got to multiply the denominator by. So if you are correcting this, if you're multiplying them both by 3, you would get 9 over 21. And if you were multiplying them both by 2, you would get 6 over 14. So because you multiply that by 3 and multiply that by 2, they are not equivalent, which is what this symbol means. Well done, and we'll see you tomorrow for some more fractions.